These children are exploring number and place value using the Digi Block program. It's a hands-on system that offers an easy and revolutionary way of teaching number sense, place value, and arithmetic operations. These third graders are packing individual blocks into groups of 10 and groups of 10 into groups of 100. This simple activity is the foundation of the Digi Block system. The Digi Block program is designed to teach the fundamental concept of the base 10 code. That is, we count from 1 to 9, and when we reach 10, we call it 1 again. The system makes this powerful concept a physical reality for children as they gather groups of 10 and pack them into specially designed smart boxes. These boxes click shut when 10 blocks are packed inside. No more, no less. 10 ones lock into a 10 block. 10 and only 10 tens fit into a 100 block. 10 and only 10 hundreds fit into a 1,000 block. Each successive Digi Block container is exactly 10 times larger than those that fill it, and always contains precisely the number of unit blocks that its size and denomination suggest. This elegant design perfectly embodies the logic of base 10. But it's the simple, repeating shape of the blocks that explains why children love to handle them.
Digi Blocks are very appealing to the children. When we first put them out at the beginning of the year, there was a packing frenzy in our classroom. We couldn't have enough space around the math table, and they would stay there for as long as they could.
They think they're playing. The students think they're playing, but as they are playing, as they're manipulating these Digi Blocks, they're really internalizing what units are, what ones are, what tens are, what hundreds are.
Okay, we're going to have a number for each column.
It's a math manipulative that attracts girls, and to me that is exciting.
There. Now, do you have a guess, Braden, how many Digi Blocks might fit on there?
16.
16. Hannah, before you finish, do you have a guess? You think it's going to be 16 also? 16.
All arithmetic operations require the ability to manipulate numbers in the base 10 system, a written code that most of us take for granted.
How many of these do you have? One of these and
One left over.
one left over. So write the 1 for the one block of 10.
But as simple as base 10 is, it is not obvious. It must be taught.
Yeah, right there. How many of these 10 holders would you need?
One block of 10 and 8 left over.
Let's see if you're right.
4, 5, 6,
Children
7,
begin
8,
by learning to count,
9, 10.
to pack,
Do you know how many that is? Let's take it apart and see.
1.
and even to unpack.
Oftentimes you'll see children unpack over and over and over and count and pack and unpack and count. And they'll do that for quite a long time, sometimes 3 or 4 months before they really know that there are 10 inside.
And when we get 10 of these, there's 100, and we put them in the bigger one. And then when we have 100 of those, we put them in the even bigger one.
The more they pack and unpack, the better, because this is it. This is the secret of base 10. If you really have it in your bones, if you really understand, when you think about the 1,000, that there is 10 hundreds in it, and 100 tens within it, and 1,000 ones, if you really get the structure, everything else then flows very simply.
The Digi Block system includes a counter. This inclined platform is used to organize packed blocks according to place value. The counter has 3 places, for ones, tens, and hundreds, and each place can hold anywhere from 0 to 9 blocks. However, when the 10th block is inserted into a holder, the entire holder is forced out of place,
Yep.
creating a need to move the now packed digiblock one place to the left.
And Len, why don't you put those last 3 tens?
When they pack the 10th one and it slides off the holder and they have to move, that physical movement is a trigger for them. And that's different. That we've never had that before in teaching number.
Would you tell me how many hundreds do you see?
2,
How about the tens?
3,
And how many ones?
5,
All right. Now, if we unpack those all the way to the ones, how many ones would you find?
235.
Perfect. Why don't you write that up?
Each of the steps required to transform a quantity of unit blocks into written digits is meant to physically reinforce the concept of place value.
How many blocks of tens would you find in there?
10 tens in each of the hundreds, and I counted, which equals 20, so I counted these 3.
You close the cover, you have it, you have a representation, and now it's 10 times as big as the other piece. There's a place for number, and I think that sense of understanding place value has been very, very helpful to our kids.
Digiblocks are designed so that the intuitive view of number and the base 10 view of numbers are one and the same. You see them both within the same physical manipulative.
The Digi Block program also includes materials designed to allow students to explore arithmetic operations. Number lines, for example, help children understand addition and subtraction in a concrete sense.
Understand? You have 4.
Every child at every stage needs the concrete stage before they can develop something abstract, and it's such a great concrete material to be able to use.
The act of packing and unpacking, if you will, is just the way of going from one view to the other view, back and forth, back and forth. So you have both of them at the same time. You're not lost when we're moving from one to the other. You still have the intuition of the one view and the computational power of the other view.
Reading it correctly and writing it correctly and showing me what it looks like. And they unpack and they show me 265 digiblocks. Or they pack them up and they show me 200s, 6 tens, 5 ones. But the fact that they understand what it looks like unpacked, what it looks like packed. And if you say, is this 265 that's all packed the same as this 265 that's completely unpacked? They say yes.
We have some big numbers here.
Once children are comfortable with a base 10 numbering system, basic arithmetic operations are introduced, but not with paper and pencil.
Many 5 and 6-year-olds aren't ready to put things in written form. And they don't understand what it means. And unless there's that deep understanding that there can only be 9 in any one place, and when there's another one, you have to move. If they don't get that, then the writing part makes no sense to them at all.
Where's your problem?
The way the DigiBlock program works is the operations are introduced as a very, very concrete physical task. So for example, if you want to divide 500 by 4, you don't introduce notation, you don't introduce the words or anything.
All right, here they are.
You just say, here's 500 blocks, can you divide them among 4 kids in an equal way?
By allowing children to explore operations in a purely physical and intuitive way, the DigiBlock program gives students of all ability levels the experience of being able to successfully solve even the most complex problems.
They will see the answer as a block of 100, 2 blocks of 10, 5 blocks of 1. The introduction of the algorithm is very natural at this point. It's something that kids love to do. You say to them, can you be so smart as to figure out in advance what's going to happen before you actually do it? That's so natural for kids to do.
Put 73 on the counter, and you're going to take away 16. Do a prediction also for me.
Children resonate to that. Children love to be clever and say in advance what's going to happen. And they love it even more when their predictions come true.
If your mother made 29 cookies, and then you ate 12 of them, how many would be left?
When children begin the transition to written arithmetic, the Digi Block counter helps maintain a critical link between the physical manipulation of the blocks and the written algorithm.
2, 3, 4, 5, 6, 7.
What did your group have, Weichi? 17. What did your group have, Shawnees? 17. Looks like we have thumbs up. I think we all agreed. That sounds like a good answer.
Kids were not going to third grade or fourth grade prepared. They didn't have the fundamental skills that they needed. But we're teaching carrying, and we're teaching borrowing, and we're doing multiplication, but it was rote. There was no excitement. There was no room for, I think of it this way and I still get to the answer, so isn't that okay? I mean, I was in a box myself. So how could I expect my 7-year-olds not to be in a box if I'm living in a box? You know, it's that whole cycle. And Digi Blocks undid that for me, because I was able to let them explore, manipulate, and if they could show it to me and verbalize what they were doing, and they were getting the answer and understanding how they got the answer, that's powerful learning. That's what we're all trying to achieve. And Digi Blocks did it.
The Digi Block program works because it embraces and emphasizes the basic simplicity of place value in the base 10 code.
Put them in a row, Brian, and see how many.
And so when you look at the way Digi Block teaches, I think you would say, gee, isn't this boring? We're doing the same thing all the time. Yes, we are doing the same thing all the time. There's not much more to it than packing and unpacking boxes.
I did it!
If I had to get rid of everything in the classroom, I would get rid of everything but the Digi Blocks. And I mean that sincerely.
How many blocks of 10? 1.
This is the teaching tool for understanding number, counting, numeration.
And how many single ones left over? Great. So how many was that altogether?
19.
They're still interested all year long. No matter when the digis are out, the children will come and say, "Oh, digis! Let's do digis!" I don't know what it is. They're just, it's like magic.